All right, y'all, part 3, we're starting with number 8. So number 8, they tell us that we have this amount of atoms within this amount of mass in a sample. So this one's kind of hard just because this might get confusing that you're like, oh, I have to use atoms and these grams together for some reason, but that is actually not correct. What you will be using though is your conversion. 1 mole is equal to 6.02 times 10 to the 23rd, and then whichever the unit for that is, in this case it's atoms. So 1 mole is equal to 6.02 times 10 to the 23rd atoms. They give me that I have this certain amount of atoms right here, so I'm going to convert these amount of atoms into moles. 1.3, instead of writing times 10, I'm going to write E because that is the same thing as saying times 10 in math world. So 1.3 times 10 to the 25th, and then atoms, AT for short, times, I have to multiply this by something so that I can get moles, because, moles are always very helpful. So I know that my conversion is 6.02 times 10 to the E, times 10 to the 23rd atoms is equal to 1 mole. So now I can see that my atoms will cancel out and I am only left with moles, which is what I wanted. So 1.3 times 10 to the 25th divided by 6.02 times 10 to the 23rd is 21.6 approximately moles. Okay, so now that we got to this point, we know that whatever is in here has 21.6 moles. The problem is telling you that the total mass of this is 970 grams, and they give you choices as to which one it could be. So what you have to do, you know that the mole amount, you can multiply the moles times the mass to find out the total mass, right? So if I have 21.6 moles of this is going to have a different mass than 21.6 moles of this and 21.6 moles of this. So I actually have to go and find the molar mass of each one of these to see what the total mass would be if I multiplied it by this many moles. So I'm actually going to write it, let's see, I'm going to write right here, CO2. I'm not going to do the subscripts just because it takes too much time. So CO2 has a molar mass of 12.011 carbon plus 15.999 times 2. ClO has a mass of, what is chlorine? 35.453, I think, 35.453 plus the O, which is 15.999. And then I have the molar mass of NH3. N is 14.007 plus hydrogen is 1.008, but there are 3 of them. So now I can go and solve this number. So 15.999 times 2 plus 12.011 is equal to 44.009. ClO, the molar mass, is that right? Did it just do the math for me? Oh my gosh, did I discover something? Plus 15.999. It did do the math for me. This is equal to 51.452. And then this one is equal to, oh, I didn't do it there. 1.008 times 3 plus 14.007 is 17.031. Okay. So now I have the molar mass of all of these. These are grams per mole. There it goes. Grams per mole and grams per mole. I know, one more time, that the moles that we found within this problem were 21.6 moles. And I have the molar mass of each one of these compounds that they give me. So I can multiply each one of these each one of this one, and this one times this many moles and see if it gets close to the 970 gram mark. So 44.009 times 21.6 is about 950 grams. 51.452 times 21.6 is about 1,111 grams. And then last but not least, we got 17.031 times 21.6 is about 367 grams. Ooh, there it goes, grams. So now we have to look and see, after I multiplied each of these molar masses by 21.6, which one is closer to 970 grams? Well, 950 seems like the closest one, which belongs to CO2. So the most likely compound represented here is probably CO2. Okay, let's move on to this next one. Greatest mass. So this one's pretty easy. I know that the greatest mass, for mass in general, I have to find out the total number, the total molar mass. So carbon is 12.011, but there's two, here, let me make that more clear. There's 2 atoms of carbon, so I have to multiply that by 2, plus 15.999 times 4. So let me do that real quick. 12.011 times 2 plus 15.999. Did I say 000? Ay, Dios. Times 4. When you add those numbers together, it is equal to 88.018. Next problem, we got 12.011, because that's carbon, times 5, because there's 5 carbons, plus 15.999, because that is oxygen, times 10 oxygens, because there's 10 of them, and that is equal to 12.011 times 5 plus 15.999 times 10. It's equal to 220.045. And my last one, I'm almost done with this one. It's pretty easy. I'm just finding the mass. 12.011 times itself, because there's nothing else, no other carbon atoms, plus 15.999 times 2. 15.999 times 2 plus 12.011 is, there it goes, is 44.009. So now which one is the largest mass? Pretty easy, I just have to look at the biggest number, which would be this one. Alrighty, so next we've got